positive symbol here. So normally in your case, you actually need to know to see what type of circuit is that. Is it what type of amplifier is that? Is it inverting or non-inverting? So for this one, we call this inverting terminal. Negative, it's equivalent to inverting terminal. Inverting terminal. And likewise, this is non-inverting terminal. So later you will see how you identify what type of operational op-amp the amplifier circuit is that. Okay, next will be the next thing you need to know is the characteristic. Why we need to know this characteristic? Because we want to analyze the circuit using KCL, Kirchhoff currents and Kirchhoff voltage law. So we have to make some assumption, meaning that we assume throughout this chapter we are dealing with ideal operational amplifier. So what is it? What it has to do with the ideal op-amp? So you need to know that it has these three characteristics. So these three characteristics showing that the infinite open loop gain. Later I show you what is infinite, what is A. Sometimes kita sebut dalam bentuk dB and decibel. And then infinite input resistance, meaning that resistance dekat dalam ni infinite, very high resistance. The resistance in this op-amp circuit is very high, which is infinite. That's why the current we assume into the circuit is zero, sebab resistance terlalu besar. So current cannot flow, equals to I1 and I2 equals to zero. And zero output resistance. So zero output resistance, meaning that all the currents want to flow through the output. Sebab the input resistance is infinite and the output resistance is zero. So these three characteristics is important in order to understand how can we analyze the circuit later. Okay, this is the first one for this morning. You need to understand, not to memorize, just to understand. This is the basic circuit configuration for inverting amplifier. So why we call this inverting amplifier? The first one you need to understand is look at the supply. Look at the power supply here. So it feeds to the inverting terminal. So we call it inverting amplifier. So next we will see how non-inverting amplifier looks like. Non-inverting when the supply will be here. Supply kita bagi dekat non-inverting terminal. If the supply is given to the negative terminal, it will be inverting amplifier. So this is the basic configuration. In your case, you will have this circuit only with different resistance value. We will only change the resistance value R1 and RF. What is RF? RF is known as feedback resistance. Feedback resistance is actually macam control lah. It tells the system when to stop. When to stop. Contohnya macam the simple analogy is your punya tangki air yang ada pelampung. Penuh dah. So bila dah penuh in certain level and you punya air yang akan flow masuk ke bawah ni, ke dalam ni akan close bila dah penuh. Bila dia naik certain level macam ni, dia akan sendiri close. So feedback ni akan normally kita buat feedback circuit ni untuk control the system to on ataupun to off at certain level. That is the normal for feedback punya configuration. Kalau you tengok circuit tu ada feedback loop, etc. is actually to control the circuit at your desired apa yang you nak. At desired level ke, at desired temperature ke, something like that. So this is feedback resistant. Sekejap dia ter-off pula. Okay, sekarang I nak you try to find based on KCL here. Based on KCL, previously I already explained to you the inverting terminal. That's why this is inverting terminal. That's why it is called inverting amplifier. Sebab the supply is given to the inverting terminal. And then this is feedback. Yeah.
Tiada slide.
Apa dia?
Slide.
Tiada slide
Tiada slide.
Okay. Okay, now normally apa yang you kena buat is actually you apply KCL at this point number 1. Hope all of you can identify which is point number 1. So I ask you to apply KCL at node 1. Apply KCL at this node. This is actually the assumption that you need to use. I mean, like the characteristic previously mentioned previously. So you need to use that as well. So apa kita punya aim sebenarnya nak apply KCL? At the end, apa yang kita nak cari? We want to find what is the relationship between the input voltage and the output voltage. So boleh cuba buat lah. Cari V input dengan V output. Sebab nanti the question will ask, okay, determine V output of the circuit configuration. So first you need to know lah V output, macam mana nak kira V output. So untuk inverting amplifier, what you need to know is look at this node 1 ni. Node 1 kita apply KCL, maksudnya current yang masuk dekat this node and then equals to current yang keluar. Dekat sini ada 3 branch kan, 1, 2, 3. So it will be I1 kan, equals to these two. I2 dengan, kenapa kita buat sini I yang masuk ke dalam ni 0? Why we assume that is 0 ampere? Remember that previously I already mentioned the 3 main characteristic of an ideal op-amp is one of the characteristic is infinite input resistance, meaning that resistance yang sangat tinggi, resistance yang infinite, meaning that bila terlampau banyak halangan kat dalam tu, you akan masuk ke tak kat situ? Tak kan? So that's why we assume the current flowing into the op-amp is 0 ampere. That's why we get this value. So that's why we got we use I equals to, so you boleh buat something like this lah. I1 which is I yang masuk equals yang flowing into the nodes equals to I2 plus 0. So these three terms kita boleh guna sebab kita nak cari V output dengan V input, the relationship between these two. In this equation, kita tak ada voltage term, meaning that we have to change this current term into voltage term. Macam you buat nodal analysis lah. So I1 it's equal to V input minus V1 divide by R1. So this is for I1. I2 equals to V1 tolak V output equals to berapa? Semua orang masih tidur ke?
Ada.
RF, good. RF. So you boleh simplify. Okay, in order to simplify this thing, you need to know one thing, which is for an ideal op-amp, V1 equals to V2. So for ideal op-amp, we have to know this as well. Macam at the back of our mind, we need to know this. V1 sama dengan V2. So whatever V2, so you nampak kat sini V2, dia connect pergi ground. Meaning that dia adalah 0 volt. So kalau V2 0 volt, V1 pun kita apply sebagai 0 lah. So dekat sini we ganti, we substitute V1 equals to 0, V1 equals to 0, kan? Minus V output over RF. So, yang ni dah 0, dia akan jadi V input over R1 equals to minus V output over RF. This is the relationship between V input over V output. Normally the question asks you to determine the V output. So you rearrange this to make this as the rumus. V output equals to minus RF divided by R1 times V input. That is the voltage output for the inverting amplifier. So previously I ada cakap pasal gain kan. Gain tu dalam amplifier kita tengok berapa decibel kan. So in other words, V output over V input known as gain. Yang ni adalah kita sebut sebagai gain. Sometimes kita tulis A macam ni. A bawah dia macam ada B kecil. That is gain. That's all you need to know about inverting amplifier. First, you need to derive the current at that node yang masuk ke dalam inverting terminal. And then you need to know that the V input, V yang masuk V1 equals to V2, and you use that two knowledge to derive the output voltage for the inverting amplifier. Okay. So to make it more understandable, we can try this example. Use the knowledge that we have earlier. So as referred to the op-amp circuit in figure 5.12, 5.12, given that the input supply will be 0.5 volt. So first, calculate the output voltage. Second, the current in the 10 kilo ohm resistor. Boleh cuba buat I give you 3 minutes. Okay, dapat berapa untuk output voltage? Ini yang paling mudah lah sebab tadi earlier we see from earlier V output over V input equals to the feedback resistance divided by the input resistance. So we use this formula. V output over V input equals to minus feedback resistance divided by R, whatever resistance given here. So the input given V input is 0.5 volt. So to find V output is we use the feedback resistance of 25 kilo ohm divided by 10 kilo ohm. This one RF, R1, RF, R1. And then kita times dengan V input. Ini yang masuk ke sini. 0.5 volt. So you akan dapat
Madam, the susunan, do you like change or this formula, the one
we discussed
VO
earlier.
over this one, like is it only for specifically this arrangement of
Yeah. This formula is for a specific for inverting amplifier.
okay.
So earlier I show you how you got to this point. I mean like how we derive based on KCL. Or you macam tak malas nak derive and then you just remember lah. Sometimes in the question ask you to verify the equation for inverting amplifier, for example. So at least you know where to start. at some point you know where to start, like, okay, I have to start at some node and derive using KCL and expand using voltage terms as you normally did in nodal analysis, something like that. So basically you just use this inverting amplifier formula to get to these questions. Okay, so here I got negative 1.25 volt. That is the answer for V output for A. And how about B? The current through the 10 kilo ohm resistor. So the current, remember earlier we derived at this point, let's say point Y. Current flow through here equals to current flow through the feedback resistor. Let's say kita buat IF. Ni I supply, let's say something like yang ni equals to 0, this current, so we not consider this one lah. So IS current yang flow through the 10 kilo ohm lah, kan? This branch is IS, sampai sini IS. So and after this point they divided into IF dengan I entering the amplifier. Since the resistance is infinite means besar sangat, besar sampai you tak boleh nak masuk. So current pun kat situ tak boleh nak masuk lah, kosong, and all is being flow through the feedback loop, feedback resistance. So in this case we want to find the current in this branch, meaning that the 10 kilo ohm resistor dekat sini. So IS equals to V input minus V minus 0 lah. V dekat sini, VY kat sini. Sebab kenapa VY kat sini 0? V positif yang masuk kat sini equals to 0 sebab dia ground. Unless kat sini dia ada bagi some value, let's say 2 volt ke, kita ambil kat sini 2 volt juga. Voltage point dekat sini sama dengan voltage yang masuk dekat positif. Yang masuk dekat negatif terminal sama dengan positif. So you always refer to dia punya partner sebelah dia. Kalau dia connected to ground, and it will be 0. And then divided by 10 lah. Divided by this resistor 10 kilo ohm. So V input was given as 0.5 divided by 10 to the power of 3. Yang ni always don't forget to include K. Normally you just ambil 10 je. Macam you tak letak pun the K value, and then at the end you punya jawapan tu salah. Sebab you tak include the 10 to the power of 3 kilo. You click, you tekan je calculator you K kan, K terms tu. And then you will get 50 microampere. This is what we discuss here is actually typical questions that will be asked in your, that covered in your syllabus. That's all you need to know. As simple as that. It's just that we still use the knowledge of KCL and KVL that you've learned in previous chapter. So dia tak susah pun sebenarnya. You just need to know, okay, this is the inverting amplifier, so this is the formula I need to use. Okay, just plug in the value. At the same time, you have to know some assumption to make your life easier, meaning that to make your circuit analysis easier. Kalau you tak tahu, let's say apa nak ganti dengan V point dekat sini, you tak boleh nak solve lah. Sebenarnya we already assume Vy equals to, sebab I buat Y kat sini, so Vy lah. Vy equals to V positif. V yang connect to V positif. In this case, V positif ni kita connect pergi ground, so 0. That's why it becomes 0. Next. Example 2. Boleh cuba buat. First, kalau I tak bagi tahu you this is inverting amplifier, macam mana you nak tahu? Normally you tengok inverting amplifier, dia ada feedback resistance yang connected to the inverting terminal. Okay, boleh cuba buatlah determine the V output in the op-amp circuit. So, you dapat jawapan? Boleh bagi tahu lah siapa yang dah siap. Tell me your answer. Before we proceed to our second part, which is non-inverting amplifier. Always start by applying KCL at node inverting node A in that case. Boleh cuba buat dulu Boleh buat tak? Berapa dapat V output?
Negatif 12.
Betul? Thank you. So I assume that with the help of the understanding to derive at KCL at node A, and you expand using the voltage terms, and that is the first thing. The second thing, you assume VA equals to VB. Voltage at node A equals to voltage at node B. In this case, voltage at node B is 2 volt, no longer 0 as previous example. So your answer is negative 12, right? So next this is the second part of our lecture for this week. We will finish by 9:30, okay? Bear with me for another 20 minutes. Previously, we learned about inverting amplifier. So this is non-inverting amplifier. Can you tell me the difference between the inverting? Non-inverting
V input
amplifier.
is at different location, madam.
Yeah, different location of the input voltage. So as you can see from the circuit configuration, the input voltage V input is applied directly at the non-inverting terminal. Non-inverting to positive terminal. So as you can see from here, this is the input voltage is applied directly to the non-inverting input terminal. That's why we regards it as a non-inverting amplifier. And the resistor one is connected between the ground and the inverting terminal. So you nampak ada one resistor yang kita connect directly to the ground and to the inverting terminal. So it regards as the non-inverting amplifier. So next thing you need to find out is what we are interested in is actually what is the value for ataupun how can we verify the term for V output over V input. Why? This is known as gain, where you normally use as decibel. Kan amplifier berapa frekuensi dia, berapa decibel, 20 decibel ke, 19 decibel ke, something like that. So that's why we're interested in to finding this value. Sebab you kalau as a circuit designer, you nak design amplifier circuit, the client ask you, oh I want this certain gain. So you need to adjust on this resistance value, kan? And supply you berapa, the balance supply you should be berapa, so that you get this amount of gain, something like that lah. I give you some example how this works in real application. So as usual, apply KCL at the inverting terminal. Where is the inverting terminal? Dekat node this one. First, you need to apply the KCL at this node, at the inverting terminal, because we are interested in the output voltage and the voltage gain. For amplifier, we only want to know the gain. What is the gain? Gain, in other words, is also V output over V input. And sometimes the question asks you to find their V output as previous punya example. Dia nak tahu V output berapa and dia bagi V input. Kan? Previously dia bagi V input at certain value. And they want you to find the value of the V output. As simple as that. So in this circuit, you need to find what we are interested in, the output voltage and the voltage gain. So as usual, we apply KCL at this node. And the current flow through here is 0. That's why it will become 1 equals to I2 plus 0 in this node. So macam biasa, you expand I1. I1 is whatever voltage dekat sini. Kan, voltage dekat sini sebab dia dah connect pergi ground, dia adalah 0 lah. Whatever yang connect dekat this line, dia akan jadi 0 volt kan. 0 volt minus V1 minus V1. Ni, V1 dekat sini. This point V1 divided by R1. And then, what else? Kita nak derive this value of I2. I2 is in this branch. V yang tinggi, V1 yang ni minus dengan V output. Yang connect dekat sini is V output. V1 minus V output divided by feedback resistance RF. Boleh ke? Okay, what's next? This is yang macam I cakap. The first thing you need to know is this one KCL, and then you expand using the voltage voltage term. And then the second thing, the most important part you need to know is always this V1 equals to V2. V1 equals to V2. Sebab dia adalah, kita assume dia adalah ideal op-amp. Ideal op-amp. So in this case, V1 equals to V2. V2 adalah this value. Whatever value given here, they will follow V1. Meaning that V1 equals to V2, which is in this case dia bagi VI. Kita ambil dia sebagai VI. So if we ganti this one as VI. So minus VI divided by R1 equals to VI minus V output. Sorry. So it becomes this. So you need to rearrange. Rearrange meaning that you take this V output lah. V output equals to 1 plus RF divided by R1 times V input. So this is the final one lah, the formula for V output. So yang ni, I hope you know how to rearrange back to this lah. It's all use the mathematic punya understanding how to rearrange the formula. Boleh ke? Okay, for example, in the final exam letter, there's a question like similar with this one, where you will be asked to verify the output of the given circuit to become this equation. So you have to derive by applying KCL dekat the terminal. Dekat this terminal. First you derive and then you expand with the voltage term. Kenapa nak expand this current kepada voltage term? Sebab we're interested in this V output over V input. We're always interested in this. It's either V output or gain. So that's why we derive current in terms of voltage and resistance. Normally resistance value will be given to you. Kan? That's why you need to find the V input or V output. That's all. Throughout this chapter, that's all you need to know. Whatever circuit you will be given, you need to know how to derive the KCL and how to expand it to get the value of the output voltage or the voltage gain. Okay, next. Okay, example. The first example. For the op-amp circuit in figure 5.19, calculate the output voltage. Calculate the output voltage. We may solve this in two ways using kita tak pakai superposition sebab kita tak belajar. Kita solve this using nodal analysis, which is kita apply KCL at node A. Macam kita buat tu lah, kita apply KCL. So KCL dekat sini apa? Current kan, current flow through here. Let's say I buat I1. Ni I buat IF. I buat IF sebab I assume this, I regard this as the feedback loop. So it will be feedback current. This will be current flow through here is 0 sebab the resistance for ideal op-amp is infinite. It's too high until no current is drawn through the op-amp. So we assume 0 lah. Perfect punya op-amp. But in real case, that will not be the case lah. I1 KCL at node A is given as at node A, small letter. I1 equals to IF plus 0. So I1 current kat sini macam mana nak cari? Kita expand into voltage term. Remember, current sama dengan voltage bahagi resistor, kan? So, I nak this value. So, I need to expand this into voltage term. So, voltage term is yang tinggi tolak yang rendah. Meaning that in this case, bila current flow through sini, meaning that voltage supply sebelah kiri ni lagi tinggi daripada yang VA. Remember that current sama dengan V higher tolak V lower divided by R. V higher tolak V lower. So in this case, V higher is 6 tolak V lower is VA. Macam mana I tahu 6 ni lagi tinggi daripada VA? Sebab current flow through the node. Kalau current flow through this way, the other way, meaning that VA tu lah lagi tinggi daripada 6. Okay? Okay, continue. 6 tolak VA divided by what value of resistor that I need to use?
Oh,
Okay, 4. Betul. And then what else? I need to derive this IF. So since the current flowing through here, yang ni connect pergi mana? V output kan? Ni V output. So since current flow from left to the right, meaning that VA yang tinggi, VA minus V output divided by feedback resistance, which is 10 divided by 10. So this is how you derive starting from KCL, from current, and then you expand using voltage term, voltage and resistance. And next thing is you need to know VA equals to VB. And always remember, once you dah derive dalam bentuk voltage ni, you need to see as VA ni sama dengan VB. This is important. Or else you cannot move forward lah. So VA equals to VB equals to berapa? VBU adalah 4 volt. So yang ni, the understanding of VA and VB ni macam like, ni boleh hafal je lah. VA mesti sama dengan VB because it's an idea of M. So you gantikan this VA, at the end you will get V output, betul tak? So let's do this. Kita gantikan 6 tolak 4 divided by 4 equals to 4 tolak V output divided by 10. So yang ni 2/4 equals to 4. Ini you simplify je lah and then you will get at the end the output equals to minus 1 volt. Boleh ke? Sama je dia punya konsep, amplifier inverting ke non-inverting. The concept is always start with KCL. I mean that you have to derive KCL at inverting terminal. So from there you expand kepada voltage term. Always remember that what you are interested in at the end is to find the output voltage. Output voltage, or sometimes the question will ask you determine the voltage gain, meaning that the voltage gain equals to V output divided by V input. V output over V input, or gain, which is sometimes expressed in decibel terms. But in final exam, I tak like mention pun like explain ataupun determine based on the decibel of 20 decibel ke, I tak buat macam tu lah. This is all, the question will always be straightforward for you to buat lah. So we have 3 minutes left, and I think that's all for today. It's a very short lecture, but I hope you can digest even tak banyak, but you need to have some idea what is operational amplifier. So let's recap. In this chapter, you need to know 4 basic configuration. The first one is inverting amplifier. The second one is non-inverting. And 2 more amplifier will be discussed next week, summing amplifier and difference amplifier. So basically, kita akan guna the same method, which is we always derive Kirchhoff's current law at inverting terminal. That is the first step in whatever operational amplifier yang you came across with. You will come across with. You're always dealing with KCL at first, and next you will always expand into voltage terms. Why I need to expand in voltage terms? Because we always interested in the voltage gain, but sometimes expressed in V output over V input, and sometimes the questions always want to know what always ask you to determine the value of the output voltage. That's all. So you expand into voltage term, and then you remember voltage into the amplifier at the inverting equals to non-inverting terminal. So and then dia macam bila you derive KCL at dekat inverting terminal, non-inverting terminal tu as you punya reference point. Berapa voltage dia? Sebab kita nak substitute V dekat node tu berapa. Sebab V dekat node yang kita derive tu always refer to the non-inverting terminal. So at the end you'll get the value of the whatever the question asks you to get lah. So next week we'll discuss on these two. And I think that's all for our chapters. I think we covered all after week 13, which is next week. On week 14 we still have lecture. Like to sum up all the things that you have learned before you final exam. Before you buat final on the, I tak ingat lah final exam kita bila, maybe 8 ke 13 February, something like that. Okay, I think that's all. Ada soalan tak?
Tak ada, madam. Tak ada.
Tak ada nanti I tanya soalan sekarang, nanti janganlah spam I punya WhatsApp pula banyak-banyak. Kalau nak tanya je, tak payah malu-malu sebab kawan awak tak nampak pun muka.
Madam,
Yeah?
later do we have like exercise for this chapter? For
Okay, I will provide
tutorial?
exercise for tutorial nombor 3, 4 dan 5 sekaligus lah.
Alright.
Oh, tutorial yang kita yang belum I provide, I will provide lah with the solution.
Thank you, doctor.
Alright, no problem. Anything else?
Doktor, petang ada lab tak?
Petang ni mungkin awak masuk lambat kot tadi. Tadi I ada discuss. Actually kita dah finish all our lab. Kita buat 5 lab je kan. Which is lab yang keempat dan yang kelima you guna multisim so meaning that we dah ada lab dah. We dah habis dah lab. What's left is kita next week kita ada lab test, but this week I open for untuk yang you request to macam tu buat latihan lah, something like that. Tapi I tak provide any apa-apa tau. I just I'll be in the lab as usual, macam waktu biasa, waktu lab session. You masuk, you buat lah apa you nak buat. You nak tanya apa, you tanya. Okay? Tapi this petang ni untuk yang group section 1/1 So untuk 1/1 petang ni list nama daripada nombor 1 daripada Ain Suhaira binti Anwar sampai Muhammad Aminuddin Hakimi bin Muhammad Fauzi. Isvaran ada ke dalam ni? Isvaran? Isvaran anak lelaki Muthu Kumaran. Tak ada Okay, tak apa. Nama 1 sampai 20 ni datang pukul 2.30 Siapa yang nama tak ada dalam list nama ni tak boleh masuk lah. Yang ada dalam list nama ni sahaja yang boleh masuk pukul 2.30 sampai 3.30. Sebab I cannot accommodate lots of students at one time. So susah I nak fokus untuk jawab soalan-soalan lah. And then the second session will start from Muhammad Badri Nazmi bin Ahmad Yaakob sampai Yap Hock Soon. Muhammad Badri sampai Yap Hock Soon pukul 3.30 sampai 4.30. So each and every one of you will have 1 hour to test or to play around with the breadboard or to make sure how to measure current and how to use the multimeter, things like that lah, to familiarize with the lab equipment before you enter your lab test, before you do your lab test. Sebab you really need to do well in lab test because your midterm is very very bad. But ada a few student yang dapat full marks lah. Congratulations. Yeah.
Madam, saya ikut jadual section 1-2 sebab saya tak ada travel credit.
Macam mana? Ikut berapa?
Saya ikut jadual section 1-2.